Welcome back to Instant Learner guys. Today we are going to discuss about combined cycle power plant for power generation. In this video I am going to show you what is the difference between simple cycle and combined cycle power plant. And we are going to completely learn about the working process of a combined cycle power plant. So before moving forward, it is request to you to subscribe the channel and press the bell icon to never miss an update from my YouTube channel. So let's start. First we get a quick introduction about combined cycle power plant. The process of converting energy in a fuel into electrical power involves the creation of mechanical work, which is then transformed into electrical power by a generator in a simple cycle, causing efficiency losses in process depending on the fuel type and thermodynamic process. The overall efficiency of this conversion is typically around 30 to 40%. This means that significant amount of latent energy of the fuel ends up wasted. Much of this wasted energy ends up as a thermal energy in the hot exhaust gases from the combustion process. So to increase the overall efficiency of electrical power plant, multiple processes can be combined to recover and utilize the residual heat energy losses in hot exhaust gases. What is the difference between simple cycle and combined cycle? The term combined cycle refers to the combining of multiple thermodynamic cycles to generate power. Combined cycle operation implies a heat recovery system that captures heat from a high temperature exhaust gases to produce steam, which is then supplied to a steam turbine to generate additional electrical power. A combined cycle power plant can achieve electrical efficiencies of up to 60%. The process of creating steam to produce work using a steam turbine is based on Rankine cycle. So let us know how does a combined cycle power plant works. The heat recovery steam generator is basically a heat exchanger, or rather a series of heat exchangers. It is also called as a boiler, or we may simply call it as heat recovery boiler or waste heat boiler, as it creates steam for the steam turbine by passing the hot exhaust gases flow from a gas turbine or a combined engine through a banks of heat exchanger tubes. The heat recovery steam generator can rely on the natural circulation or utilize forced circulation by using pumps. As the hot exhaust gases flow past the heat exchanger tubes in which hot water circulates, heat is absorbed, causing the creation of steam in tubes. The tubes are arranged in sections or modules, each serving a different function in the production of dry superheated steam. These modules are referred as economizer, evaporator, superheater, reheater, and preheater. I have explained all of them one by one. You can go and watch on my YouTube channel. The saturated steam from steam drum or one-through system is sent to the superheated to produce dry steam, which is required for a steam turbine. Preheaters are located at the coolest end of heat recovery steam generator gas path and absorb energy to preheat heat exchanger liquids such as water, thus extracting the most economical wide amount of heat from the exhaust gases. The superheated steam produced by the heat recovery steam generator is supplied to the steam turbine, where it expands through the turbine blades, imparting rotation to the turbine shaft. The energy delivered to the generator drive shaft is converted into electrical energy. After exiting the steam turbine, the steam is sent to condenser, which rotates the condensed water back to the boiler. That's all guys. Thanks for watching this video with tons of love to my Instant Learner family and to be Instant Learner family. This is me, Engineer Bilal. You are watching Instant Learner. We'll see you in next video. Goodbye.